So in this short video, what we'll do is we'll try and work our way through the various determinants of duration and try and figure out how duration changes when these determinants change. Specifically, we'll take a look at how duration changes with the yield to maturity, let's call it Y, how duration changes with the coupon rate, let's call it C, and how it changes with the maturity, let's call it TM. So let's begin with the yield to maturity first. So to understand the impact which this yield to maturity has on duration, let's recall the definition of duration. Duration, we have defined it as D is equal to minus dp over dy, which is basically the rate of change of the price of a fixed income security as the yield changes, or in general the risk factor changes, that divided by the current price of this fixed income security. Okay, so that's how I would define my duration. And here I'm not qualifying duration as either effective, dollar, Macaulay, all that, right? I'm just saying duration as a basic concept here. Now, when it comes to it, I would assume that this yield is continuously compounded when I need it. Okay, so that's my basic definition of duration. Now let's try and figure out how I can check how this duration behaves as, let's say, the yield to maturity increases. So to do that, let's do this. Let's plot the price versus yield relationship of any fixed income security. Specifically, let's consider this security to be like a fixed coupon kind of a bond. And let's see if by looking at this profile, I mean P versus Y, if we can figure out how D reacts to changes in Y. So let's plot it. So if you were to plot this relationship, we know that it's an inverse relationship. It's shown here by this blue curve. And we know that it's kind of a convex relationship. So let's do this. Let's place ourselves, let's say, at a current yield of 6% first. Note the price. The price is marked by this. And let's do this. Let's plot a tangent to this blue curve at this current yield of 6%. So that tangent is plotted as this one. Okay. Now let's do this. Let's bump the yield up. That means let's move from 6% to, let's say, 8%. And let's redo what we've just done. And that is, note the price that we land up at on the blue curve. And then let's also draw the tangent at that point given by the green dashed curve. Okay. So from these lines that we've drawn, the tangents and the level of the prices, what do we note? We note a few things, and that is, as the yield changes, and in our case it moves from 6% to 8%, we note that the price goes down. Okay, so that part is clear. It's an inverse relationship between prices and yields. The other thing which we note here is that the slope of this curve, I mean P versus Y curve, it has become less negative. Okay, it was more negative at 6% and now it is less negative. If you were to take a look at the magnitude of this slope, right, then the magnitude, let's write it down as this. So magnitude of the slope at 6% was actually greater than the magnitude of the slope at 8%. Okay, so the price has gone down, the magnitude of the slope of P versus Y has also gone down. Okay, so if you were to come back to our formula, the formula was D is equal to minus dP over dy, which is the slope of the tangent, that divided by the price. Then it doesn't tell us too much about how duration would change as Y changes. Why? Because both the numerator and the denominator have gone down as the Y has gone up. Okay, so had these changes been in different directions, we could have got a conclusive evidence of how D changes with Y. Okay, so this particular interpretation of duration doesn't quite help us in terms of answering this question, how does D change with Y? So let's switch our definition or interpretation of duration. Let's do that. So let's now move to the other interpretation of duration, and that is duration is equal to a weighted average of the times at which this particular instrument pays us something. Let's assume that at time ti, this instrument pays us some cash flow CFI. Okay, so this another interpretation of duration is what we learned under Macaulay duration. Okay, so let's do this. Let's try and use this interpretation, and now let's try and see what happens as y increases. Before I do that, let me write down what this weight is. Okay, so this weight wi, which I attach to the cash flow that is paid out at time ti, I would calculate this weight as the present value of this cash flow I, that divided by the total price of my fixed income security. So this y, where does it go and figure in? It figures in computing this present value. That means it figures in this discounting, and overall it figures in determining the price of my security. So if the y were to change, the wi will change both on account of the numerator changing as well as the denominator changing. So let's now do this. Let's now do this, quick experiment of shifting the y, let's say from 6% to 8%, and let's try and note what impact this y, increase in y, will have on the wi. The impact would be this. The first thing that we would notice, the denominator, which is p, would go down. So that part we already know. Okay. What happens to the numerator? Now in the numerator, let's now bring in this assumption that this y is continuously compounded. The numerator would look something like this. It would have a coupon. Let's assume it's a fixed coupon bond, and it would have a discount factor. That means it would have a e to the power minus y times ti. So if the y were to go up, then the impact of this change in y would be felt more heavily by those coupons which occur later on. That means those coupons whose time at which they occur, which is ti, is higher. Okay, let me rephrase it. So I would be saying here that as y goes up, longer dated cash flows are discounted more heavily as compared to shorter dated cash flows. Okay. Why? Because longer dated cash flows would see the brunt of this increase in y a lot more because their ti is higher. So if that happens, what we actually see is, let me write it down, a basically redistribution of these weights. Now weights, they always sum to 1, okay, because the sum of the PVs of all cash flows is equal to P. Therefore, the sum of all weights is still 1. But when you change the y, what happens is a redistribution of these weights, in which the weights for longer dated cash flows, that means ones for which ti is higher, they tend to go down, and the weights for shorter dated cash flows tend to go up. Okay, relatively speaking. So therefore, that's what I call redistribution of weights. Now, if this redistribution of weights happen, and if duration is indeed a weighted average time to receiving all these cash flows, that means that now you are attaching a higher weight to shorter dated cash flows at the expense of the weight which you attach to longer dated cash flows. And therefore, what it would do is it would bring down duration. That means duration, if you interpret it as an average weighted average time to receiving cash flows, then yes, increase in yields will bring down duration. So therefore, what you can write down in a very mathematically fancy way is that the sensitivity of duration, I'm using the partial sensitivity here because duration is not just a function of a single determinant. So the sensitivity of duration to this interest rate factor, which in this case is the yield, is negative. Okay, so we are saying that as the yields go up, duration comes down. So this is the net rule of thumb that you should remember. Now let's move on to the next determinant. The next determinant is coupon. So again, what I'll do is I'll reuse the same definition or interpretation of duration, and that is a weighted average time to each cash flow. Okay, so with this as my interpretation, let's write down again the definition of WI. It's the present value of any given cash flow, CFI, that divided by the total price. Now, Let's again assume that it's a fixed rate coupon bond. That means CFI would basically be a constant. It would be basically present value of sum C that divided by P. Now let's do this. Let's do this experiment of, let's say taking a look at two bonds. They are similar in all respects, such that apart from the fact that, let's say, one bond has a higher coupon as compared to the other. Now keep one thing in mind. When we were looking at the impact of D versus Y, right, we could very well have been doing this analysis for the same bond. We were just looking at a bond and we were looking at the impact of how its duration changes when Y changes, and Y typically can change if, let's say, interest rates change. Okay. Here what we will do is we will take a look at, let's say, comparative duration between two different bonds. They are similar in respects in terms of, let's say, maturity and frequency of coupons, but what they differ in is in terms of the size of the coupon. So if the coupon increases, what happens? Look at the weights. The first thing that will happen is the numerator goes up, right? That means the cash flow I, which in this case is C, goes up. Okay, so that's the first thing which happens. The next thing that you can say would happen is the price of this bond would go up, right? Because this bond is paying you a lot more. So the denominator would also go up, right? Now, what would this have an impact on WI? What impact would it have? Again, what happens is it's a redistribution of weights, okay? This redistribution of weights is relative to the final cash flow. The final cash flow is what? It's the face value plus the coupon. Okay. So when you are determining the price of this fixed income instrument, in this case, the bond, then there is a role played by the final big guy. The big guy is the face value plus the coupon. And there is a role played by all the cash flows which occur prior to this final redemption, and which is just the coupon. Okay. So if you have increased the coupon, what have you done? What you've done is that you have, let me phrase it right, what you've done is you have brought forward a certain chunk of the total value of this bond, which is P, and you are now paying a certain chunk of this P earlier than the final guy. Okay, a zero coupon bond does not pay you anything before the final guy. It only pays you something at maturity, right? Or its redemption. It pays you its total face value. By starting from that zero coupon bond and, let's say, introducing progressively higher numbers for the coupon, what you are progressively doing is you are bringing forward a certain proportion of this total value of the bond, and you are paying it earlier and earlier. Okay. So therefore, what you are doing is you are increasing or redistributing the weights again. That means WI is going up at the expense of the final guy, which is the W of TM. Okay, so when that happens, you are attaching a lower and lower weight to the final guy, and you are increasing the weights of the initial few guys. All right. So again, if you take a look at this interpretation of duration, you are basically increasing the weights to shorter dated cash flows, and hence the duration goes down. Okay, so as coupon goes up, duration goes down. Mathematically fancy way, it would write as the sensitivity of this duration to changes in coupon is negative. Okay, that was my second determinant. Now let's move on to the third one, and that is the time to maturity. So to understand the impact of duration versus TM, let's begin with the simplest possible instrument, and that's a zero coupon bond. Okay. Now, a zero coupon bond, I know, pays everything in one shot. It pays everything at maturity, right? So therefore, if you were to perceive duration as a weighted average of all times at which the instrument pays something, then in the case of zero coupon bond, it only pays you stuff at a single point in time, and that's the maturity TM. That means the weights for any of the initial time points is 0, nothing is paid, and the weight for the final cash flow is 1, and therefore it gives you that the duration of a zero coupon bond is equal to its maturity. By the way, here I am working in this world where the yields are continuously compounded. If they are not, then we know that the modified duration has to be computed, which is maturity adjusted by 1 upon 1 plus y tau. Okay, so forget about that. Now let's come back to this rule which we have in front of us, and that is, if it's a zero coupon bond, the duration is equal to its maturity. Okay, now let's do this. Let's introduce a certain coupon. Let's move away from this concept of a zero coupon bond, and let's now try and play with TM. Okay, let's try and increase TM because that's the variable which we are interested in. Now, before I move ahead, the general rule of thumb which my ZCB tells me is that duration increases as time to maturity increases, and since the two are equal, it tells me that the sensitivity of change in duration with respect to time to maturity is 1. Okay, that's what ZCB is telling me. Now, when I introduce coupons and again try and play with my time to maturity, what happens? When I increase my time to maturity, what have I done? I have pushed the big guy. The big guy was future value plus coupon. Okay, I have pushed it into the future. I have pushed it more and more into the future. So when I do that, what happens? The weight which I attach to this TM, okay, one is that weight might change, right? Because if the weight is all about distribution of weights amongst different cash flows, that's the first thing which happens. The second thing that will happen is you are now pushing the final time of receiving a cash flow higher and higher. So this is the final time for receiving the last cash flow. You are making it higher and higher. In this weighted average, that means there will enter a last time for receiving a cash flow which is now higher. Why? Because the maturity of this bond is higher. So this impact will go in and increase duration. Why? Because you are adding to this mix a time which is very high. So that part will increase duration. Okay. What about this part? When I increase time to maturity, I am also doing that same thing of redistribution of these weights. When I push this final guy back, am I not inserting more coupon payments? Imagine you are comparing, let's say, a 7-year bond versus a 10-year bond. Okay, and this bond pays, let's say, semi-annual coupons. By increasing the maturity from 7-year to 10-year, you have now introduced new times into this weighted average, times such as 7.5, 8, 8.5, 9, 9.5 and 10. These are pretty high times which now come into this weighted average. But what have you also done is that you have included additional cash flows, coupons which happen at 7.5, 8, 8.5, 9, 9.5. These are additional coupons which have now been introduced, right? Now, these additional coupons, what they would do is they would have a similar impact which our analysis of D versus C brought out, right? That these coupons will bring forward a certain chunk of this value which this bond has to deliver, okay? Because these coupons pay out these values earlier than what the final big guy would pay out at, okay? So therefore, here we are talking about two opposing effects. There is one effect which is coming from including higher and higher times to cash flows, and there is one effect which comes from redistributing of these weights, okay? So net, what happens is that the sensitivity of duration to the maturity is still positive. Okay, duration does increase when the time to maturity increases, but this increase, because of this second opposing effect, has a diminishing nature to it, which means that if you were to write down the second derivative or the derivative or the rate of change of this rate of change of duration with time, then this guy would come out to be negative. Okay, that means duration does respond positively to increases in time to maturity, but the rate at which this duration is increasing goes down with time. Okay, so we can actually take a look at the last two effects, I mean coupon as well as time to maturity, in a very quick graph. Let's do that. So this is the graph. What it shows us is a few things. Look at the blue graph first. The blue graph is the blue plot is duration of a zero coupon bond with respect to time to maturity. Okay, so see, it's a linear graph. Remember I said that the sensitivity of duration to time to maturity for a zero coupon bond is 1. Okay, see, it's a linear graph with a constant slope. Now take a look at any point in time. So let's say for this 20-year maturity, let's take a look at durations of various bonds: zero coupon bond, a discount bond, a par bond, a premium bond. Okay, that means I am increasing the coupon in this direction. So when I increase the coupon in this direction, see, duration is going down. Okay, so that means the sensitivity of duration with respect to coupon is negative. That's the other thing which we note. Now take a look at sensitivity of duration with respect to time to maturity. Now this I have already done for zero coupon bond. If you were to take a look at this for any other bond, let's say a discount bond, a par bond, or a premium bond, still this guy is positive. Why? Because as the time to maturity increases, duration is increasing. All the three curves are moving up. But notice this fact that the three curves are moving up at a diminishing rate. That means the second derivative is negative. Okay, so what we've done in this short video is we've laid down our rules of thumb to determine how duration would be impacted if any of yield to maturity, coupon, and time to maturity is played around with.